The actual know-how that you need to understand to be able to solve problems for this chapter is actually quite small. For example, from the very beginning, what we have discussed so far for this chapter, what you have to remember, if I just say it out in words, the Coulomb's law,
500 manual top.
the idea of permittivity of free space, how the graphs, individual graphs are drawn, how the combined graphs are drawn, and for the capacitor part, what we have seen in our last class is that while charging, the capacitor is going to slowly gain up voltage, and given enough time, it will have the same voltage as the source, at which point the current in the circuit will decrease, and eventually become zero. And also, capacitors store energy, not charge, because the total charge of a capacitor at any point of time is actually zero, consider both the plates together. And what is the atomic level structural change that happens inside a capacitor so that it can actually store energy? How does the capacitor store energy within itself? That's by the atomic level deformation of the atoms. A part 2 tomader buja lagbe. What are the parts that you do not require, what we did cover in last class, that how does the battery work? What's the whole point of having a battery to have its full voltage? How does the Coulomb of Joule actually work out through the entire circuit? That's not essentially a part of this chapter. What you don't have to understand or remember is the basic idea of the working procedure for how the capacitor practically works. You don't have to know this. There are some mathematical equations that we're going to see in today's class, which is going to bring us to the end of this lecture of this chapter. So it's not essentially very difficult for you to understand, or if I give this thing in entire exactness, the part that you have in your notes is essentially what you're going to have to go through, which in my opinion is actually quite precise. Everything that I have discussed beyond the scope of the class notes is not going to be required for you to be able to solve the problem. So for those who are starting to hate this chapter or starting to hate physics in general, please don't walk this path. I beg you. I did discussion to a much deeper level of the deeper level beyond the scope of the syllabus, because that was warranted for last class. But you don't have to know these stuffs to be able to solve problems. Can I put my point across?
Yes, sir.
Yes, sir.
Yes, sir.
So actually, yes.
Sir,
Bolo,
sir, I had a question from previous class.
go ahead.
Sir, when current flows through the capacitor, does the number of electrons in the negative plate increase as it gets charged?
Yes.
And the electrostatic potential energy is converted to electrical energy when there's no battery connected across it and a resistor is connected to the capacitor.
When it drains?
Yeah, when it drains.
Yes.
Exactly.
Yes.
Okay, this was my confusion. Thank you, sir.
No problem.
স্যার
বলো।
ব্যাপার ছিল যে এনার্জি কিভাবে স্টোর করে স্যার ওটা একটু এক্সপ্লেইন করতে পারতেন আবার?
Energy stored by the atomic level deformation of the dielectric medium that is introduced in between the two plates. The atoms have their center of negative and positive charges deformed, which is a deformation of the electric field pattern. That's how they store the energy.
বাট স্যার এখানে কোনো চার্জ তো স্টোর হচ্ছে না, তাহলে আবার এনার্জি কিভাবে স্টোর হয় স্যার?
Because there is no actual difference of number of total electrons and total protons, but the placement of the electrons and the protons are getting moved.
Sir.
Yes.
You said the energy is stored within the deformation of the atoms, right?
Yes.
It's just like elastic deformation, where if you stretch out a spring in some way, you deform it, and energy storing that.
Well, let's see. Yeah, there is a bit of a difference. I mean, the idea is somewhat similar, but it's not essentially the same. Whenever we apply physical force on a spring material, or if we make physical deformation to an object, the atoms do not actually deform. In a physical deformation process, the intermolecular space become higher or less. The atoms, spherical atoms remain spherical atoms, but their spacing can become more or that become less. That's what happens for physical deformation, which is visible by eye and measurable by instruments. But for the electrostatic deformation that we discussed last class, the atomic level deformation, the atoms undergo deformation, which is not visible by eye and most likely not even measurable by equipment, unless you have extremely precise equipment which can actually measure the field pattern of the electrons exclusively and also the nucleus exclusively, which is pretty difficult to do in true sense.
I understand, sir.
So single line answer for your question could go like this, that physical deformation affects the intermolecular spacing, whereas electrostatic deformation affects the atom's actual shape, not intermolecular spacing.
Energy is stored in that state, right, sir?
Yes.
Okay.
All right. So the next part that we have to understand, which comes from this graph, is that this is the typical graph for an ideal capacitor. An ideal capacitor means that this capacitor has the capability to withstand any high value of voltage. So the more voltage you apply to it, the bigger amount of charge you can store in the plates. So this is a Q versus V graph for a capacitor, where this graph goes to the origin, which means if it is at zero potential, zero charge is stored, the more voltage you apply, the more charge you can store. This is going to be a straight line that passes through the origin. The gradient of this graph is C, which is the capacitance by definition. C equals to Q by V. This equation is true because this is a straight line going origin. So like V equals to IR, we can directly use this equation, no problem. And the area under the graph gives the energy stored in the capacitor for a specific supply voltage. Area under the graph means area under the capacitor line and the voltage axis, not the Q axis. It's important. So Q by V graph area under the graph would say capacitance. So that would be given by half into Q by V. So this half QV is essentially showing that if you consider the amount of storage, let's say this is an actual graph. So let me take this out and actually start scribbling. So if you consider this is the amount of graph that we have, and let's say the voltage that is given over here at this point. So this is the amount of voltage that you are gonna charge in a capacitor by. In this case, in that case, the capacitor is gonna be able to store this amount of charge. So the area of this triangle is gonna give you the amount of energy stored. So that would be equal to half into V into Q. So that's where the half is coming from. This half is coming from the basic idea of triangle area. And then we can replace this equation for individual replace. For example, Q can be replaced as Q equals to CV. That was coming from the definitive equation of the capacitance. So that gives you half CV square. That's one formation. So it can form from here to here. Alternately, we can also go to this expression where V was replaced in terms of this thing. So if we subject V from this equation, what is going to be the value for V? Should choose a bit thicker line. Or what if I subject V from this equation, what should that be? V equals to Q by C, right? So if you replace V over here, you're gonna get half Q into Q by C. So that's replacing V. So you're gonna get half Q squared by C. Some people can also write this as Q squared by 2C. That's perfectly okay. I prefer to write it in this version because that way I can think in my head that the half is exclusive and all of these things are having interchangeable values. Here we have one expression that this is given that this is more preferred. This is more preferred because this preference is coming from the idea that if you have a certain capacitor that you are doing your maths with, or if you have a certain capacitor that is given, within the operating voltage limit, the capacitance of this capacitor is going to be constant. So C has a fixed value. And how would you operate this capacitor with is highly dependent on how much voltage did you connect with the capacitor, which is going to be your source voltage, or if you have a potential divider circuit, it can also be the potential divider value of the circuit as well. That's a different scenario. I'm going to show you some circuit after a while. Don't worry about that. It's going to come up. So the available voltage that will be applied to a capacitor can be very easily seen or obtained from the quotient or from the circuit. So the amount of energy a capacitor should be able to store is very easily calculated by using this expression half CV squared. And another beauty is that whenever we are using this equation for one specific capacitor, C is basically a constant because we are not considering the capacitor will be changed over the duration. We might as well change different property of the circuit, for example, voltage source, resistor, blah, blah, blah. So if your C is a constant, practically speaking, your entire energy stored will be only varying because of the availability of V across the capacitor component. So this will be used in a lot of equations for a most preferable version, but this does not essentially mean that the other two equations are unapplicable. They are also equally applicable, but you might have to do two more steps or one more step to be able to solve, to be able to calculate the same energy stored in the capacitor if you want to use either of these expression. That might also be possible. So they're not unuseful or they're not incorrect. This is typically more convenient to use. That's why it's labeled as more preferred. There is nothing very difficult about that. Here comes the discharge situation for a capacitor. So this is a certain circuit that we have over here, which is going to work with discharging and charging at the same time. I'm going to explain this circuit. So let's have a look. Let's say this is a circuit that we have. So this is a supply voltage Vs, and then we have a capacitor over here. This is a two-way switch. This is the fixed end. The switch can move from left and right. So let's say this is the left. Should I label left and right? Do you guys understand left and right properly? Left is here, and right is here. Okay. So I'm gonna refer to this switch as left and right. So I would not label different parts of this thing. So this switch can flick from here to here like that. This is the fixed end. So this end can move over here. So what is happening over here, that with the supply, if we connect it to the left, the capacitor is gonna get charged. Because we did not show any resistor in this part of the capacitor is gonna charge to the maximum Vs value within a very short amount of time. For ideal theoretical scenarios, let's say the battery is theoretical, which means it doesn't have any internal resistance. The capacitor is theoretical and all the connecting wires have zero resistance. In that case, the capacitor will charge to voltage Vs in 0 time. But 0 time is not practical because the connecting wires do offer some resistance. Battery has some internal resistance irrespective. So it is gonna charge up to the maximum supply voltage pretty soon. So let's say currently the capacitor is fully charged, and now we're gonna flick the switch onto the right side. Then this capacitor can drain to this part. So if I just do a bit of a change in this circuit to make it a bit better visible, let's say I'm gonna rub off this part of the switch and drop the switch over here. So if we do that, now this capacitor is gonna start working as a temporary source for this resistor. This resistor doesn't have to be a resistor, it can be an electrical physical component, or let's say it can be an LED, it can be a bulb, filament bulb, it can be fan, light, loudspeaker, computer, TV, fridge, whatever. This is what we call the load resistance through which the energy is to be used. So we can connect it to the right. Now the capacitor is going to work as a temporary source and is going to start draining energy. This will produce a current in this direction. So current is going to flow through this path. How this current is going to work out, or how does the capacitor's voltage, charge stores, these things are going to be varied. They are shown in this graph. Where is this graph? They're shown in this graph. So I might as well take this graph and place them side by side. Let me select this image. Oh no. Yeah. Oh. Why can't I select this image? Oh, okay. Interesting thing happened the other day. Kids, guess what?
Your cat had more kittens.
You might not be able to guess them. Maybe if you might not be even interested in doing guessing games in physics class. One of the new students who actually did start with me and eventually quit, I'm not gonna name this person, told me that that they think that I cannot teach physics. This was the first time, and I took it like a champ.
Sir, they don't know what they're talking about.
I hope so, but that's the first time for me.
So I get it. Okay, probably with meta.
I'm not gonna name
স্যার
this
মা
person.
বাপরে কিছু বুঝানোর ছিল ওটা বুঝাইছে নিশ্চয়
Sir, her name, her address, and everything else.
No. you don't have to do anything. I mean, this is the first time for me, and there's a first time for everything. I mean, the reason I'm telling you this, kids, this thing, because if any of you feel the same way, you're welcome to leave without even telling me this. I mean, you're perfectly good. Or you can tell me this and eventually leave. If you feel like that you're wasting your time over here, please leave. Have help somewhere else. This is good. I mean, there's no point wasting time and resources if you're not getting benefited. If you plan that these classes cannot prepare you for your A levels, it's not working in your brain, you cannot catch up with the space of the class, or whatever problem that you have that you think is unsolvable, or I am not providing enough adequate care or service to make that problem solvable, then you are very much welcome to leave, any of you. So that was my this statement is why I told you the information in the first place. So moving on. So what happens whenever we connect this switch to the right side over here, and the capacitor is going to start to drain. Okay, the capacitor is going to start to drain itself through this capacitor through this right side circuit. And as the capacitor is going to start to drain, well, you have to understand that initially the voltage of this capacitor should be exactly equal to the supply voltage, because this was connected to the left side on the first place. So initially, if I consider that I equals to V by R, the initial value of voltage V by R, the initial voltage was Vs. So the initial current would be very high. And as the time goes by, the voltage is going to reduce. So the current is going to also reduce as well. And as more charges flow out, so electrons will be actually flowing through this path. So electrons are going to flow in the anti-clockwise direction from the negative plate through the resistor to the positive plate, and conventional current flow is going to flow the opposite way. That's the basic idea of conventional current and electrons. You know this thing, historical mistake, we still stick to it. So, and as a result, that stored charge in the capacitor is also going to be reducing. As it so happens that this graph of the charge versus time, or current versus time, or voltage versus time, and all the three shapes of the capacitor discharge has this common shape. This figure is not drawn to scale. This is a sketch shape, which is representing that all the three variables, whether I, Q, or V, they're all going to change with respect to time by the exact same shape. But obviously, if you plot a graph of a current versus time, you're going to have ampere versus second. If you plot charge versus time, you're going to have Coulomb versus second. If you plot voltage versus time, you're going to have volts versus second. So that's going to be a defined unit that you can have on this axis. And the starting point is what we represent as 0. 0, for example, I naught means the value of I at t equals to 0. Similarly, Q naught means the value of Q at t equals to 0. So initial value of that variable, and as time goes by, this is going to be reducing by this pattern. How does this graph, what is the mathematical equation of this line is somewhat described over here. So okay, before we actually get into the graph, these are the three discharge equation that we have. Those three graphs that you saw, they were gonna undergo exponential decay following this ratio. So this is the ratio that we have, E equals e to the power minus t by RC, where RC is defined to be a very specific constant for a circuit, not for the capacitor. It's very important. Have you look. The product of RC, R is the resistance of the circuit, and C is the capacitance of the capacitor. If you do the product of these two things, this is a property of a combined circuit. So for example, the RC for this circuit would be the product of the capacitance and the resistance. And this is defined as a very specific component that's called the time constant of a circuit. Have a read. What does this thing? I mean, where all of these things are coming from, I'm going to tell you in a bit. But one thing that I'm not telling you is that how did this equation came into existence? This equation actually come into existence through a bit of integration, which can be derived by the differentiation equation. Then we can go by the definition of the capacitor. The derivation process is not included in a syllabus, so I'm not gonna show you this in the class. If you're interested, I can help you after the class recording is paused. If you're interested, you can stick to that point. But how this equation came into existence is not being shown here. So that's out. One thing is very important is that the subject of this equation, I, Q, or V, they are the value after t time, or I can say this is the remaining value. Not the lost value. What it means that if you start with I naught amount of current in the circuit, after t time, you're gonna have the existing current in the circuit is gonna be I. If you start Q naught amount of charge that was stored in one of your capacitor plates, after T time, the remaining charge in one of the plates is gonna be Q, and so on and so forth. And this tau is defined as time constant. How does this definition come into play? That is actually shown in here, I think, in this part. Do we have that? Exactly, over here. Have a look. This is a narrow exponential curve which has an expression of, I'm going to write the exact variable over here, e to the power minus t by rc. That is the change factor which is causing this graph to undergo this curvature. So this one shows that if we replace t equals to tau in any of the discharge equations, we get this thing. So t equals to tau in any of the discharge equations. So if we place that I equals to I naught e to the power minus t by r. So we're doing this for I, for example. We could have also done this for Q or V. That's perfectly all right. So I equals to I naught e to the power minus t by rc, tau by rc. Tau is a symbol for rc. So this rc is sometimes written as tau, which is called the time constant. What I'm trying to show you is what the time constant is. So if I place it over here, then if t equals to tau place, then in the place of t, we have replaced tau. And by definition, the rc is also tau. So we have written over here tau by tau, which makes it 1. So I equals to I naught into e to the power minus 1. The numerical value for e to the power minus 1 is 0.37. There's more digits to this. We have written this number up to 2SF, so 0.37, which means the remaining current will become 37% of the initial current. In other words, I can say if t equals to tau, then I equals to 0.37 of I naught, or Q equals to 0.37 of Q naught, or V equals to 0.37 of V naught. That's the basic idea of T.
Sir,
tau.
can you explain the last part again, sir?
This one, this writing.
Sir, last part to je apnar RC er part take to bujhine, like e to the power minus RC.
Bujhine,
Time constant part to bujhine, sir.
The product of RC, the product of these two quantities is what we are defining as time constant. And that I have not shown you the definition yet. I have not gone into the definition. I'm showing you the mathematical derivation of this part. What this 37% coming from? Using this 37% information, we can give the definition of time constant. Have a read at the definition. the amount of time in which the initial value of charge or voltage or current reduces to 37% of the initial value is called the time constant of a discharging circuit. So for a certain specific circuit, the amount of time within which the initial values are going to reduce to 37% of original, that amount of time value is what we're calling the time constant of a circuit. One of the easier way that I can make sense with you to make a better understanding, that in your radioactivity chapters, in your O levels and also in AS level, you have come across the idea of half-life, right? Have you guys have come across the idea of half-life?
Yes, sir.
This thing, half-life. Yeah. So what actually happens within that half-life duration of time? The available initial number of atoms decay to half number, or initial mass of that substance decays to half of its mass. It converts into something else. It doesn't perish. It doesn't become gone. It converts into something else. So it doesn't remain as its own self anymore. Within that time, half of the initial substance get converted to something else or decay into something else. And that's the definition of half-life. So that factor for the half-life equation goes like this. Let's say if we have initial number of atom is n, let's say n naught, then the remaining number of nuclei should be n naught into e to the power minus half. In this case, for the capacitor, I equals to I naught into e to the power minus 0.37. That's the basic idea. So the same concept. I'm talking about similarities here. For the atomic physics case, the time amount is within which the number of nuclei or amount of mass to begin with reduces to half of its original value was defined as the half-life. And the time constant is a similar thing. The amount of time within which the initial quantity becomes 37% of the initial amount. So the I reaches 37% of I naught, or Q reaches 37% of Q naught, or V reaches 37% of the V naught. That amount of time is what we're defining as the time constant. I'll take questions. Obvious.
Sir, I had like two questions.
Follow.
One concerning an earlier graph you showed, like Q versus V, I think.
Follow.
In that graph, what does the Q represent?
Q represents the amount of charge stored in the capacitor, altogether the total charge stored in the capacitor under the effect of V voltage applied across its plates.
But sir, didn't you mention charge can't be stored?
That is the point, that charge cannot be stored. But whenever we say a capacitor is storing Q charge, we refer to charge stored in any of the plate or one of the plate of the capacitor. Total charge stored in a capacitor is 0. But,
positive and minus.
Yeah, but exactly. So whenever we use this phrase that charge stored in a capacitor is Q, we mean that one of the plate of the capacitor has plus Q charge, the other one obviously has the minus Q charge. So we talk about the magnitude of the charge of one of the plates.
Then that makes sense. Okay. So the other question is like the number 37%. Is it just a coincidence that it came from e to the power minus 1, or was there any sort of planning to get that 37%?
There is a mathematical procedure. That mathematical procedure happens to be that C was given by Q by V, right? C was given by Q by V. This is a definitive equation for C. So
Yes,
if we there was some derivation for this thing, dq equals to so Q equals to CV. So we could also write that dq should be equals to C into dV, and I think Q equals to I actually forgot how did the derivation come in, but at some point in your integration part there was 1 upon something, which actually brought even the idea of ln, which eventually got reconverted into e to the power. But you had something like this. Let's say integration of 1 by x dx. This gives you ln, right?
yes, sir.
So somewhere in the integration process, ln came in, and after reverting the ln with appropriate proportion, we got the e to the power. That's where the e to the power comes in, and that e to the power thing is an output of the mathematical integration process. And just to define what the value of RC is, we are considering that, well, if we place that exact amount of time t, or which is RC, on the numerator side, we can cross them out very easily, which becomes sub 1. Or what we're trying to define is, what we're trying to do over here is that if t equals to tau, then how much is this t? T is the variable time, tau is a fixed time. So if we, how can we define the tau using the property of t? So if we allow the circuit to discharge by tau amount of time, what is going to happen? This is going to happen.
So it's just the simplest way of connecting time and the current and charge and voltage of this capacitor.
Exactly. It's a simple mathematical way of connecting these two things. Yeah, that's very well said.
Okay, I see, sir. Thank you.
Sure. Yeah, Shubro.
Sir, what does the N stand for? N equals to N0. That part.
That stands for the remaining number of nuclei for an atomic case. And N naught represents the initial number of nuclei for an atomic case.
So all of these equations are related, right?
These two equations are not related by virtue, they are related by similarity. Or in other terms, I can show you, to make my answer more elaborate, I can show you one thing is that if you consider a radiative graph, what happens is that you are gonna have, let's say you start from 100 for a radiative graph. Let's say this is the number of nuclei that you're trying to plot over time. So you're gonna have 50 after a certain amount of time. You're gonna have 25 after that exactly same amount of time is gonna be 25. So you're gonna have another point over here, 1 point over here. Then after exactly equal amount of time, let's say over here, you're gonna have it 12.5. Then you're gonna have 6.25. So it's gonna work like that. So you're having an equal proportion of drop after every half-life. For a capacitor, that's gonna work by 37%. So if you start with a fixed amount of current for current versus time over here, if you start with 100 value of current, after the tau amount of time, that's gonna become 37. That's gonna be one of your point. And after another tau amount of time, let's say 2 tau, that's gonna be 37% of 37. How much does that come? Can somebody tell me? I don't see my calculator around. Okay, I found it. 0.37 into 37, how much do you get? 13.7 about. So let's say here is 13.7. So after twice the time period time, you're gonna have this value. After another one, you're gonna get another value. So after that is gonna be 0.37% of 13.7. So each of the remaining value is gonna get multiplied by 0.37. So the change factor over here was half. You are multiplying each available value with half to find out the new value. The change factor over here is 0.37. That's the difference, or that's the similarity. See if that makes sense.
Basically হচ্ছে কি আপনার ডিফারেন্সটা সেম থাকতেছে, মানে হাফ লাইফের কনসেপ্টে জাস্ট হাফ লাইফ না আছে।
হ্যাঁ, মানে the decay is exponential, but the decay amount is not same. The graph is not linear. I mean, it's not becoming half and half. মানে 2 half life পরে 0 হয়ে যাচ্ছে না. It is becoming continuously half after every time. বুঝা যাচ্ছে?
জি স্যার।
শুভ্র, বুঝা গেছে তোমার কোশ্চেন আনসার পাইছো? I guess so. Shubhra is not responding. All right, so that's about the capacitor equation, which is going to be useful for us in a lot of cases. We're going to see about the implication of this thing right after a while. হ্যাঁ বলো। Or no, বলো, sorry.
স্যার ওই যে গ্রাফটা ওটা কিসের গ্রাফ?
এটা
হ্যাঁ
এটা I versus T হইতে পারে, Q versus T হইতে পারে, voltage versus time হইতে পারে. Irrespective of the variable that you choose for the y-axis, the shape would be exactly same.
এটা কি ডিসচার্জিং এর সময়?
Exclusively discharging এর জন্য।
কিন্তু স্যার ইনভার্সেস টি তো হবে না, রাইট? একজন করে প্লিজ। শুভ্র, I asked you to respond earlier, so wait. একটু ওয়েট করো, আমি আশা করি আবার তোমাদের ব্যাক করছি, ডোন্ট ওয়ারি। বলো।
তার মানে যখন ডিসচার্জ করবে এটা কখনো জিরো হবে না, রাইট?
Yes, exactly.
তার মানে কিছু চার্জ সব সময় থেকে যাবে এখানে, এরকম কিছু?
Yes. What this essentially means, that the decay is happening exponentially, means it will never become zero theoretically, but there is a certain accuracy level or precision, not accuracy, there is a certain precision level for our measuring instrument. I mean, you cannot develop a measuring instrument that can measure up to infinite number of decimal places, can you? Or can we? That's not pragmatic. মনে করো হচ্ছে একটা certain measuring instrument এর last measurable digit হচ্ছে ধরো 3 বা 4th decimal place. So technically speaking, if you measure with a measuring instrument at certain point of the drop, it would show you zero reading, because that low value would be registered in your device as zero. This is why for practical cases, we can consider the capacitor is fully discharged at some point whenever we are discharging it through a resistor. But if you want to theoretically make this capacitor to become entirely discharged, the only logical way we can totally discharge a charged capacitor, so this is a charged capacitor that we have, the only way we can completely discharge it if we short circuit it with its own. That way you can say the capacitor is fully discharged, like zero is zero, solid zero. But as long as you have a resistor over here, and if you start to discharge through a capacitor, it's going to discharge and discharge less at a less rate over the time. So mathematically it will never be completely discharged. বুঝতে পারছি?
জি স্যার।
আচ্ছা, হ্যাঁ শুভ্র বলো, কি বলছিলাম?
স্যার আমি বলছিলাম যে কিন্তু n ভার্সেস t তো আবার সেম হবে না স্যার, বিকজ 0.5 -0.5 যেহেতু উপরে।
মানে বুঝি নাই
স্যার, এর উপরে পাওয়ারটা যেহেতু -0.5, সো n ভার্সেস t গ্রাফ তো আবার সেম হবে না।
I didn't say they are gonna be same ever. I said that they are similar in virtue, in similarity. They have a relationship in similarity, that they are both undergoing some exponential decay. For the relative case, that change factor is half. For the circuit discharge, capacitor discharge case, that discharge factor or reduction factor is 0.37.
Yes, sir, I got it.
Sure, thank you. Sajid bolo.
স্যার ওইখানে তো বলতেছে যে মানে গ্রাফটার মধ্যে বলতেছে যে ক্যাপাসিটর কখনো মানে ক্যাপাসিটর ইনফিনিটি গেলে আপনার ইয়ে হয় মানে জিরো চার্জ হয়ে যায় তাই না?
Yes.
তো তার মানে মানে ও তো এই চার্জটা যেটা ছোট অল্প অ্যামাউন্টে চার্জ হোক বড় অ্যামাউন্টে চার্জ হোক
I bolo, sorry, I bolo.
মানে বেসিক্যালি আমি বলার চেষ্টা করতেছি যে এই যে ও মানে জিরো করতেছে না অথবা একটা ইয়ে দিয়ে পুরো একটা ডিভাইস দিয়ে আমি মেজার করতেছি অথবা একটা লাস্ট পজিশনে যাওয়ার পরে ওখানে জিরো দেখাচ্ছে বাট স্টিল ওখানে তো চার্জ আছে তাই না? এই যে চার্জটা যে রাখতেছে ক্যাপাসিটরটা এটার ভিতরে এটা কেন রাখতেছে, কিসের জন্য রাখতেছে?
Because you are allowing, there are two different ways I can answer this question. সেটা হচ্ছে যে for the inside of the capacitor, all the atoms did not reach back to their original spherical shape. That's one way to say it. The other way to explain this is that the method of discharging that you are allowing, that is through the resistor, is not allowing enough current to flow by so that it can discharge all of its charge completely. Because the idea is that V equals to IR. As the capacitor is discharging more, the available voltage across its space is becoming small. So the current is also becoming small. As the current is becoming small, it is discharging even less. So it is never discharging completely to get rid of all of its charge. Because the further it discharges, the drive to discharge is becoming less. Like eating kachi, that example that I pulled out last class. The more I eat, the slowly I eat because I don't have to eat faster.
আচ্ছা আচ্ছা ওকে থ্যাংক ইউ স্যার।
Sure. So let's go for the next part, which is going to be the last part of the capacitor discussion, I believe. Yes, I'm correct. That is, how do you deal with combinations of capacitor? This is an interesting thing. So let's go for it. So these are the two different type of combination of capacitors. Here pops two different formula. Why these formulas work is not a part of your syllabus. I think, is it a part of your syllabus? Or no, it is a part of your syllabus. These are proven here. Okay. The reason I've given the formula first is to just to make sure of the case that you understand what this is about. আমরা রেজিস্টারের কেসে আমরা যেটা শিখছিলাম সেটা ছিল হচ্ছে এরকম যে for resistor combinations the total series resistors is calculated by the sum of the resistors, right? And as for the parallel resistor, the parallel resistors total resistors is calculated by the sum of the inverse. So R1 inverse plus R2 inverse plus R3 inverse plus dot whole inverse. This is what the parallel resistors is about. Capacitance is just ulta jabe. Have a look. Total series capacitance is given by a formula similar to parallel resistance. So the formulas are actually changing shape. Whereas total capacitance for the এটা কেন হয় সেটা আমি বলতেছি আপাতত জাস্ট ইনফরমেশনটা মাথায় নাও এটা মানে why does this happen? I'm coming to that. For the parallel part, the total capacitance will be calculated by the basic sum. So this formula for series combination or parallel combination is exactly opposite compared to what happened for the resistor combination. That's one easier way to remember. কথা হচ্ছে এটা কেন হবে? আচ্ছা আরেকটা জিনিস দেখাতে ভুলে গেছি, সেটা হচ্ছে the tau equals to যে RC, এটা যে একটা হোমোজেনাস ইকুয়েশন সেটা একটু প্রুফ করে দেখাইতে হবে। এটা এখানে নাই সামহাউ, এখানে লেখা হয় নাই। So tau equals to RC means it to be for it to be a homogeneous equation, tau is the amount of time, which means এটা unit হচ্ছে second. তার মানে RC, the total product of unit for the RC quantity that also has to be second. How does that work? RC total unit product হবে omega ohm into farad. Now
ছিল তো
ছিল
স্যার অন্য পেজে ছিল।
আচ্ছা আমার একটু খেয়াল করি। ও আচ্ছা এখানে আছে, সরি ইয়া হ্যাঁ এই প্রুফটা ইম্পর্টেন্ট, এই প্রুফটা আমি আলাপ করতে ভুলে গেছি। এই প্রুফটা একটু দেখো সবাই, না বুঝলে আমাকে জিজ্ঞেস করো। ইটস ভেরি সিম্পল, বাট সবাই একটু দেখো।
স্যার একটা কোশ্চেন করবো।
হ্যাঁ হ্যাঁ বলো, শিওর।
আচ্ছা না, ঠিক আছে, মানে আর তো এখানে রেজিস্ট্যান্স অফ ক্যাপাসিটর।
Resistance of capacitor বলে কিছু না, capacitor has capacitance. R means the resistance of the load.
স্যার একটা কোয়েশ্চেন ছিল।
বলো।
স্যার লাইক বইতে পড়ছিলাম যে লাইক ইফ আমরা একটা স্ফিয়ারের মধ্যে if we allow চার্জ টু পাস থ্রু, তাহলে হচ্ছে স্ফিয়ারের মধ্যে চার্জটা যতক্ষণ না পর্যন্ত ইউনিফর্মলি রিডিস্ট্রিবিউট হতে পারছে ততক্ষণ ওটার কোনো মানে ক্যাপাসিট্যান্স নাই। সো ক্যান ইউ এক্সপ্লেইন দ্যাট? Like they're saying that when charge is placed on the sphere, the charge distributes itself so that there is one value of potential for the whole sphere.
আচ্ছা, এটা ক্লাসের পর আলাপ করতেছি। I need to see I need to see what this is about, and I need to have some precursor to get to that part.
Okay, sir.
ক্লাস আমি রেকর্ডিং স্টপ করার পর একটু থাকো, I'll explain more briefly.
স্যার
বলো।
স্যার ক্যাপাসিটর তো একটা ট্রেডিশনাল ব্যাটারির মতো ইলেকট্রন পাম্পের মতো কাজ করে না।
No.
As in it loses charge.
Yeah.
So that electrons are responsible for the PD across the components connected to the capacitor.
Yeah.
Okay, sir. Thank you.
Sure. I'm eating something. Is that sound audible through the channel?
Yes.
Yes, sir.
Like very?
বেশি না, বাট চলে।
ওকে, আমি যে সারাটা দুপুর ঘুমাইছি, I didn't have lunch. তারপর উঠে 5:30 থেকে ক্লাস নেওয়া শুরু করছি, so I'm having a bit of a snack that was given to me by my mom. Chira bhaja with chanachur and rosun and piyaj and ada and stuffs. It's heavenly. Food made by moms are heavenly. You guys don't know this yet because you haven't gone out of your houses and had to deal with the rest of the world. So you guys don't know that yet. But believe me, food made by moms are heavenly. So getting back to the point, here we are. So why should this formula have this shape? Have a look at this thing. Let's say this is a series combination for a certain capacitor, and let's try to understand how this series combination is going to work. Let's say now one of the things that I really want you to understand very minutely. Have a look. This is a supply voltage Vs, and this is the positive end, this is the negative end. Let's say the electrons are going to go out from the negative end and it's going to come across to the positive end. Let's say when we have connected the situation like this and the capacitors have completely charged up. Essentially, if the source gives out Q voltage, let's say the amount of charge that actually is given out and absorbed by the source is Q. Let's say the magnitude of the charge that was moved in the process of making these capacitors fully charged was Q. Then essentially this would mean that from this negative end of the battery, Q amount of negative charge should go up to this plate. What I really want you to see is that this part of the capacitor, is a segregated part from the other circuit. Do you see that? Because this left plate is not physically connected to the right one, is it?
No, sir.
So whenever we are going to supply minus Q charge to this plate by means of basic induction or by the basic working principle of capacitor, the left plate should give out Q amount of negative charge. That charge will be pushed to this one. Same thing is going to happen to this one. So because this capacitor will accept minus Q charge, this will be giving out minus Q charge to the left one. So this is becoming minus Q, this is becoming plus Q, and eventually that minus Q charge that will be given out from this capacitor is going to be eventually traveling to the battery, and everything is perfectly charged at this state. What you need to see, the amount of circuit that is within this rectangle. What is the total charge of this amount of circuit?
0, sir.
The total amount of charge of this part of the circuit is still 0, because this right plate is now plus Q charge. This left plate for the rectangle that I've drawn is also minus Q charge. So the total amount of charge within, these segments is still 0. So they're giving out and accepting equal amount of charge. Is this idea acceptable to all of you?
জি স্যার।
So what capacitors aren't identical?
Yeah, for the timing, let's assume for that timing, let's assume the capacitors are not identical. Even if the capacitors are not identical, can you have different amount of charges on these two opposite plates? Try to understand. This capacitor is accepting minus Q charge, this plate is accepting minus Q charge. So shouldn't logic imply that this plate should also have to give out plus Q amount of minus Q amount of charge, so that they are together equally charged? Because like I said, capacitor don't store charge. What do they store? Energy. Total charge stored by both the plates of a capacitor at any given time will always be zero, which means the negative plate and the positive plate should always have equal amount of opposite charges. Is that correct?
So the properties of the capacitor are irrelevant to the induction loss, right?
Sumaya, you are correct. What you asked is correct. Yeah, কি বলছো? আরেকবার বলো, আবিয়াস বুঝি নাই।
The properties of the capacitor are irrelevant to this induction law of no charge being stored. Like, it doesn't matter what capacitor you use.
Exactly. It doesn't matter how much capacitance is how much is the capacitance of the capacitor. By virtue of capacitor, it is always going to have equal amount of positive and negative charges on its opposite plates, irrespective of its capacitance value. So if this plate has plus Q charge, because this rectangular thing is a disconnected part, the other plate has to have minus Q charge. This would imply that all the capacitors which are connected in series, they must have equal Q amount of charge stored across them, or in each of their plate there would be Q charge stored. Have a look. এখানে যে Q charge বের হয়ে Q charge কিন্তু এখানে ভেঙে যায় নাই. This Q charge did not get redistributed or didn't get divided into multiple different parts. Shubho, do you have a question?
Yes, sir.
বলো।
I was thinking that, স্যার এটা এত সিম্পলি হলো কিভাবে যে মানে মাইনাস কিউ চার্জটা, আচ্ছা মানে প্লাস কিউ তো ওইভাবে মুভ করতেছে না স্যার, মাইনাস কিউ যেভাবে বলছেন আপনি।
What do you mean?
আচ্ছা না না স্যার লাইক মাইনাস কিউ শুধু মুভ করছে কারণ শুধু ইলেকট্রনস মুভ করে।
Exactly.
Yeah.
Plus Q is left behind.
আচ্ছা তাহলে স্যার প্লাস কিউ না স্যার, যখন মাইনাস কিউ একটা প্লেট থেকে আরেকটাতে জাম্প করতেছে, isn't the plus q getting neutralized?
এখানে ইলেকট্রনস একটা প্লেট থেকে একটা প্লেটে জাম্প করতেছে না। We are considering them to be ideal capacitors capable of handling any amount of voltage. So there is no electron that is leaking across the plates of a single capacitor. The electrons can only move through the connecting wires of the circuit.
How the charge is passing?
Charges are not passing. Charges are being pushed out because of induction.
Yeah, I think I got it.
Beautiful. In that case, please lower your hand. It makes better. So this is what is happening over here. So this is what I'm trying to say, that whenever Q charge is released from the source, each cell is now storing Q amount of charge. What makes this thing happen? That if we write the equation, actually, let me just hold it at this stage. That C1 equals to Q by V1. If we say, let's say there are three capacitors, let's say capacitor 1, capacitor 2, capacitor 3. Similarly, so V1 equals to Q by C1. In the same way, V2 should be equals to Q by C2 and V3 equals to Q by C3. Because this is a series circuit, by means of Kirchhoff's second law, Kirchhoff's second law tells us what? Total voltage gain in a single loop of a circuit equals to total voltage drop. That's why by Kirchhoff's second law, this is going to be true. Can you agree on this one? Total gain from the battery equals to total drop by the capacitors. So Vs equals to V1 plus V2 plus V3 because of the series circuit. So if we just replace all this value, now here comes Q by CS. CS would be the to be calculated total capacitance of the series combination. So that's what we are using as the symbol of the total capacitance for the series combination, capacitance series CS. So Q by CS equals to Q by C1 plus Q by C2 plus Q by C3. If we cut out the Q from all the parts, we get this expression. That's what makes the total capacitance of a series combination to have a value like this, which can be also rewritten in the convenient shape that I personally like, which I teach all the kids from O levels. That is, other than having this format, preferably write it in the inverse form so that you are less prone to do calculation mistakes. This was better. এই পর্যন্ত বুঝে গেছে সবার?
জি স্যার।
এখানে কি স্যার বেসিক্যালি প্যারালাল একটা সিরিজ আসতেছে
কি
মানে বেসিক্যালি এখানে উল্টা হচ্ছে।
হ্যাঁ, ফর্মুলার শেপটা উল্টা হচ্ছে, বাট কেন উল্টা হচ্ছে সেটা আমি এক্সপ্লেন করলাম।
হ্যাঁ সেটা বুঝছি, মানে আমি বলতেছি
হ্যাঁ, ফর্মুলা শেপটা উল্টা হচ্ছে। আসাদুল বলো।
তো স্যার এই ফর্মুলা কি মনে রাখা লাগবে না দেয়া থাকবে?
বিউটিফুল কোশ্চেন। দেওয়া থাকবে।
থ্যাংক ইউ স্যার।
Sure.
Sir, can you call this the total capacitance of the circuit?
Of the series combination.
The series combination. Okay.
Now everyone have a look at this one and see if you can make sense out of it. Just check this out. What is going to happen in this case? Whenever Q charge is going to go out from the negative end of the battery, that Q charge is going to get distributed across the capacitor because they are currently in parallel. So if let's say over through this plate we have Q1, then this will be Q2, this will be Q3. And from the idea of conservation of charge, or which is the Kirchhoff's first law, Kirchhoff's first law is about I equals to input current equals to output current, which can also tell you that within a given amount of time, input charge equals to output charge. So if you go for consider for this junction, the amount of charge that is going in is the charge that is coming out of the battery, which is let's say Q, and the amount of charge that should go out should be the sum of Q1 plus Q2 plus Q3. So this is basically input current equals to output current sum, but whenever we multiplied that current by time, because they would all work for the same duration of time, we can convert that equation for charge. That also equally works. So this is basically coming from Kirchhoff's first law. So read through, and if you have any question, ask me.
Sir,
Hmm.
Sir, did you say that why the capacitors have the opposite formula to resistor? I mean, resistors in series have R1 plus R2 plus R3, but capacitor has the completely opposite form. So did you say the reason? I wasn't in the class.
Yes, we just discussed why that would be applicable for a series circuit. Now we are trying to discuss why that should happen for the parallel circuit.
Sir, I didn't get why Vs is equal to V1. No, I get it.
Because they're parallel circuits. So yeah, you can consider this loop where voltage gain equals to voltage drop, or you can consider this loop, voltage gain equals to voltage drop, or you can consider the other loop. I mean, you can consider three different loops with the three different branches. Because the second law tells you that total voltage gain equals to voltage drop. That's where this is coming from.
It makes sense.
Yep. Coulomb, কাউকে বুঝতে সমস্যা হচ্ছে? আমি এটা ডিটেইলসে আলাপ করতেছি না because it's very simple. If you have any question, ask me, or if you don't, we'll move on.
Sir, the amount of charge going on to each branch, it will depend on the capacitance, right?
In this case, yes. The one that has a bigger capacitance would essentially take more voltage to sustain equal voltages, or I can write it in this format. What? Okay. So I can write it in this format. For example, let's say Q equals to CV. All right. The idea is that because of the parallel combination, the V should be same for everyone. So যার C যত বড় হবে তার Q টা proportionality তত বড় হইতে হবে, or vice versa. বুঝছো কি বলছি?
জি স্যার।
Good.
Sir,
বলো।
we draw capacitors as parallel metal plates, but the
Yes.
we use in lab are like cylindrical.
Physical capacitors can have a lot of different shapes depending on the location you're using, depending on the temperature of the environment. Capacitors come in a lot of different shapes.
But the basic idea of just two parallel metal plates is always
somehow placed apart from each other with a insulated medium in between.
Okay, sir.
So that's it. So we're gonna start solving some problem from the worksheet. I'll give you 4 and 5, 9 minutes of break. We'll resume at 9. We'll resume at 8:55.
আচ্ছা স্যার আমাদের কি এবার মানে
হ্যালো
হ্যালো স্যার, হ্যাঁ শোনা যাচ্ছে স্যার।
Yes, sir.
Hello, sir.
Hi. So we might as well try to solve some problems from here. So let's say, okay, let's leave them a bit big. Choose a problem that I want to solve. Okay, this is a good one. Where is copy? And আচ্ছা এমনি করে কপি করলে হবে না, ডাইরেক্ট এডিট মারতে হবে। Okay, let's have a look at this question. পুরো কোশ্চেন দেখো। এমনি করে তো আসলে পড়ান যাবে না।
স্যার গ্রুপে দিছে?
না, গ্রুপে একটু পরে দিব। এখান থেকে দেখাই তাহলে। এখানে পুরো কোশ্চেন একসাথে দেখানো যাচ্ছে না। পুরো কোশ্চেন একসাথে না দিলে বিপদ। ডিটেইলস এখান থেকে দেখেন তাহলে। ক্যাপাসিটর কম্বিনেশন প্রবলেম একটু পরে দেখাবো। আগে আমি গ্রাফে একটা প্রবলেম দেখাই নাই, মানে ফিল্ড রিলেটেড গ্রাফে একটা প্রবলেম দেখাই নাই। দিস ইজ দ্য প্রবলেম।
স্যার
জি বাবা,
স্যার এই ওয়ার্কশিটটা কি গ্রুপে দিছেন?
না, এই যে ক্লাস শেষ হওয়ার পর দিয়ে দিব।
ও আচ্ছা আচ্ছা, সেজন্য করে দিই।
এইটা দেখো, এখন দেখা যাচ্ছে প্রবলেম দেখো, পড়া আছে কিনা, ফন্ট সাইজ ঠিক আছে?
ঠিক আছে স্যার।
আচ্ছা, so we have two charge particles A and B which are separated by a total distance of 6 cm in between each other. The variation with distance d from A of the electric field strength along the line AB is shown in figure 3.2. So you can see electric field strength which is entirely on the positive side. Question will say electron is emitted, and electron is emitted with negligible speed from A and travels along AB. So we released an electron with negligible, which is 0 speed from here, and it is gonna travel along AB. So see the relationship between electric field strength and potential. So it answer is simple. E equals to minus dv by this dr. এভাবে ক্লিয়ার হয়। অথবা এটা একটা ইয়া আছে, কি বলে, ওয়ার্ড আছে। ওয়ার্ডটা হচ্ছে এরকম, এটা হচ্ছে কত নম্বর কোশ্চেন? 18 নম্বর কোশ্চেন। ওয়ার্ডটা দেখাই। কই গেল এই যে 18 নম্বর কোশ্চেন দেখো, field strength equals to potential gradient. Correct sign or directions discuss, মানে হচ্ছে কেউ যদি field strength equals to potential gradient লিখে, জাস্ট এক্স্যাক্টলি এই সেন্টেন্সটা লিখে তাহলে 1 মার্ক পাবে। আর যদি কেউ লিখে field strength equals to minus potential gradient, তাহলে directly ওই একটা সেন্টেন্সে 2 মার্ক পাই যাবে। বুঝছো কি বলছে?
স্যার এটা আবার
If you write field strength equals to potential gradient, which you are meaning that E equals to dV by dr, you're gonna get 1 mark. If you write field strength equals to minus potential gradient, then you're gonna get 2 marks for that sentence automatically. ওই কারেক্ট সাইনটা আলাদা করে মার্ক করছে যাতে করে এই সেন্টেন্স এটা দেখা না যায়, মানে field strength equals to potential gradient এটুকু প্লাস আর মাইনাস ছাড়া থাকলে 1 মার্ক, মাইনাসটা থাকলে অ্যাডিশনাল একটা মার্ক, মোট 2 মার্ক। বুঝছো কি বলছে?
Yes, sir.
জি স্যার।
Example report দেখো, the great majority of answers were simply V by D. This was of course quite incorrect because since V was defined as the potential and D is the distance, this was a serious misunderstanding. Potential gradient is not V by D. Potential gradient is dV by dt, dV by dt or dV by dr. E equals to V by D is a very exclusive formula for a very exclusive case for the scenario of parallel plates. Apart from that scenario, you cannot use V equals to V by D at any other scenario. Even if you have two flat plates which are charged and are kept at some angle with each other, you simply cannot apply E equals to V by D. You cannot. E equals to V by D is exclusively applicable for two flat plates which are parallel to each other for that scenario. So this was a very large misunderstanding as they are saying. But if you give the answer as the field strength equal to the negative gradient potential. So yes, exactly. If you write a minus sign over here, or if you write the word negative gradient potential gradient, you scored that 2 marks immediately. বুঝে গেছে? I hope so. পরের কোশ্চেনটা দেখি। The variation distance d from the A of the electric field given. আচ্ছা, আমাদের ফার্দার কোশ্চেন বলছে the area below the line of graph AB of figure 3.2 represents the potential gradient between A and B. Use figure 3.2 to determine the potential difference of A and B. So what I want you to understand that the whole concept of square counting is never going to leave you.
স্যার
বলো।
স্কোয়ার কাউন্টিংটা একটু দেখায় দিবেন কিভাবে করব?
আল্লাহ না,
স্যার পারি না।
আচ্ছা শোনো, স্কোয়ার কাউন্টিং আমি আমার ও লেভেলসের ব্যাচে কোন একটা ক্লাসে দেখাইছিলাম। না
স্যার
তোমাদের ক্লাসে তো মনে হয় স্কোয়ার কাউন্টিং দেখাইছিলাম তোমাদের ক্লাসে স্কোয়ার কাউন্টিং। বলি এস এর কোন একটা লেকচারে আমি মনে হয় স্কোয়ার কাউন্টিং অনেক ডিটেইলসে বুঝাইছিলাম, ঠিক আছে? তোমাদের ক্লাস শেষ হোক, তোমাদের গ্রুপে আমি ওই ক্লাসের ওই টাইম ইনস্ট্যান্সের লিংকটা দিয়ে দিব, ওখান থেকে তোমরা দরকার মতো দেখে নিও, অথবা এই ক্লাসের ডেসক্রিপশনে দিয়ে দিতে পারি, সমস্যা নেই, ডোন্ট ওয়ারি।
স্যার
বলো।
P5 এ কি আমাদের স্কয়ার কাউন্টিং রিলেটেড এরকম কোনো গ্রাফ আসতে পারে?
না, P5 এ স্কয়ার কাউন্টিং নাই, পিরিয়ড।
That's good.
Okay, so here you will have to do some square counting. তারপর বলছো use your answer in B to calculate the speed of the electron as it reaches point B. So এখানে যতটুকু potential difference আছে, এই total potential difference হচ্ছে তোমার V. That electron will travel under the effect of a potential difference V. So the energy gain KE equals to work done equals to হচ্ছে VQ. Remember, energy equals to VQ. Energy equals to VQ. That comes from the definitive equation of voltage. Voltage is given by energy per charge. So energy equals to voltage into charge. So in this case, you have to do that thing. Kinetic energy equals to about half mv square. So VQ এর ভিটা হচ্ছে potential আর half mv square এর ভিটা হচ্ছে speed. কেউ কি বুঝতেছো কি বলতেছি?
স্যার VQ ওটা কি বললেন? দাঁড়ান।
আচ্ছা দাঁড়াও, মিস করছি। Hold up. I selected it but I cannot copy it. কি মজা। যেটা বলতেছিলাম সেটা হচ্ছে এরকম, মামুন জসিম কি জেগে আছে? আমাকে আমাদের কি পুদিনা পাতা শেষ হয়ে গেছে না আছে? পুদিনা পাতা কি শেষ হয়ে গেছে না আছে? আছে কিছু? তো পুদিনা পাতা দিয়ে তোমার টং চা খাও। সরি অ্যাবাউট দ্যাট। সো এখানে আমি যেটা বলছি সেটা হচ্ছে ke of the electron should be given by the voltage of the two plates across the two plates or between the two charged particles multiplied by charge of the electron. So এই ke equals to হচ্ছে half mv square. এই ভিটা হচ্ছে ছোট ভি, আমি ইচ্ছা করে ছোট ভিটাকে স্পেসিফিকলি লিখলাম যাতে করে আমি এটাকে ভোল্টেজের সাথে কনফিউজ না করি। ইকুয়ালস টু ভিউ ইনটু চার্জ অফ দ্য ইলেকট্রন। এখানকার এই কনস্ট্যান্টটা তোমার এই ফর্মুলা দেওয়া থাকবে, এই কনস্ট্যান্টটা ফর্মুলা দেওয়া থাকবে, এটা আসবে হচ্ছে এখান থেকে। তো সবগুলো বসালে তুমি এখান থেকে ভিটাকে ক্যালকুলেট করে বের করবা। এই হচ্ছে ওয়ার। বুঝা গেছে?
Yes, sir.
জাস্ট টু মেক সেন্স, দেখো এখানে দেখো আছে সব। ওই যে ইলেকট্রনের আমাদের লাগবে হচ্ছে ইলেকট্রনের মাস অফ ইলেকট্রন, রেস্ট মাস অফ ইলেকট্রন হচ্ছে এটা, আর এটা লাগবে হচ্ছে চার্জ অফ এলিমেন্টারি চার্জ, এই এলিমেন্টারি চার্জও দেওয়া আছে। সেটা হচ্ছে ইলেকট্রনের চার্জ আর এটা হচ্ছে ইলেকট্রনের মাস। সো এগুলো বসাইলে আলটিমেটলি ক্যালকুলেশন ঠিকঠাক মতো করতে পারলে এই আনসারটা চলে আসবে, সমান ঝামেলা নেই। আচ্ছা, এটা গেল। এবার ডি নাম্বার বলছে use figure 3.2 to determine the value of d at which the electron has maximum acceleration. Use figure 3.2 to determine the value of d at which the electron has maximum acceleration. So maximum acceleration হবে হচ্ছে যেখানে field strength সবচেয়ে বেশি। Try to think about it. Acceleration comes from F equals to QE, right? F equals to ma. That's the second law. আর F equals to QE. ইলেকট্রনের চার্জ তো ফিক্সড। তার মানে যেখানে E এর ভ্যালু সবচেয়ে বড় সেখানে আমাদের F এর ভ্যালু সবচেয়ে বড় হবে, সেখানে অ্যাক্সিলারেশন সবচেয়ে বড় হবে। আর তুমি গ্রাফে দেখো আমাদের এই টোটাল গ্রাফে পটেনশিয়াল ভ্যালু, সরি, E এর ভ্যালু সবচেয়ে বড় কোথায়? At which location within this 6 centimeter space is the highest value of E?
0 centimeters.
Or we can say nearest to the charge particle A. Or you can say at the starting point of the journey. অনেকগুলো ওয়ার্ডিং হতে পারে, আমরা ওয়ার্ডিং গুলো এখান থেকে দেখি। কোশ্চেন নাম্বার 18 এ বলছে at d equals to 0. No, there will be only one word. Oh, works. Master you also. This calculation was completed successfully by most candidates. Okay, good. তারপর বলছে হচ্ছে without any further calculation, describe the variation with distance d of the acceleration of the electron. Without any further calculation, describe the variation with distance d of the acceleration of the electron. So what they are asking, as the electron is going to travel from A to B, as the electron is going to cover this distance, how will the acceleration of the electron vary? How will the acceleration of the electron vary? So এটা কি রকম হবে?
It will decrease for some time and then it will again start to increase.
Can you specify up to which distance it will decrease from the graph?
4 centimeters, sir.
Exactly. So you better incorporate that value because you are trying to describe. So adding numeric value to your description always is a good thing. So
এটা বলতে হবে না যে 0 হয় স্যার?
কি 0 হবে বলতেছো? 4
acceleration 0 হয় না?
এখানে কি acceleration was given by F equals to QE. So Q তো হচ্ছে ইলেকট্রনের চার্জ। এই পুরো গ্রাফে কোথাও কি E এর ভ্যালু 0 হচ্ছে? দেখো, it is becoming minimum at this point, but is that 0? So no. What this graph essentially means, have a look. This graph means that the electric field strength is working in the same direction for both the charged particles. This should essentially tell you, because the electron is going to make its journey from over here to over here, this has to be both the charged particles A and B are pushing the force onto the electron in the same direction. So because the electron is going to travel in this way, you have to understand A has to be a negatively charged particle and B has to be a positively charged particle. Do you understand my point? They have to be oppositely charged so that their applied force direction is same, so that the electric field strength is also same. That's why the entire electric field strength graph is existing on the positive side or one side of the graph. এই লজিকটা কত আগে মালা পড়ছিলাম, remember? Okay. So The way I would prefer to write the description is that from d equals to 0 to d equals to 4 centimeter, the electric the acceleration of the আমাকে describe বলছে না describe and explain বলছে শুধু describe বলছে okay from d equals to 0 to d equals to 4 centimeter, the acceleration of the electron will decrease. From d equals to 4 to d equals to 6, the acceleration will increase, but the final acceleration will be smaller than the initial acceleration at d equals to 0. But I'm going to say that this increased value, the last value of acceleration, will not be as big as the initial value, because this one is a much bigger value, this one is a much smaller value. If I only say it's going to increase, that much imply that it's going to be really high and big. Because I can compare these two numbers over here. I'm going to add that last bit, which might not be in the mark scheme, but I'm going to add that up. পড়ে দেখো কি লিখছে মার্ক স্কিমের পর এক্সামিনেশন করে বড় কোন কোশ্চেন থাকলে আমাকে জিজ্ঞেস করো I love this bracket. Gives a hard check on the understanding of the students. Hard check. Any suggestion that acceleration becomes 0 or that there is a deceleration scores 0 out of 2 immediately. No matter how much correct information you've put there.
Yeah, that's villainous actually.
That is
That's
not villainous.
pretty.
No, that is not villainous. That's exactly why I said the hard check. This bracket puts an extremely hard check on the understanding of the students. তুমি অনেক কিছু লিখলা, but তুমি গিয়ে পরে বললা যে at some point that the particle decelerates or at some point the acceleration becomes 0. That would be an entire misinterpretation of the whole scenario. Who am I? এটা তো জ্যাকি চ্যানের একটা মুভি। এটা তুমি আসলে কে? Who am I? কথা বলো। চ্যাট উইন্ডোতে কিছু লেখো। I might as well consider you as an unknown person and kick you out. Okay, then tell me who you are. Okay, you're gonna have one more chance to reply the prepared answer. Who you are.
আজকে এরকম রানা স্যার ক্লাসে হয়েছিল কি জানি কোভিড-19 না করোনা ভাইরাস লিখে ঢুকছে
I'm gonna wait 10 more seconds and then I'm gonna kick this person. Five more seconds. Good.
So you kicked him?
That's better. And I should also turn on my waiting room so that he does not get into automatically. Where is my waiting room? There we go. Whatever. কারো যদি চুলকানো অন্য জায়গায় করুক, আমার ক্লাসে আমার গ্রুপে এসে চুলকানো দেখানোর দরকার নাই। For example, আজকে ক্লাসে for the very first time I put a roll number in front of my name, if anyone have seen it or not. But I did not discuss my name.
I thought you watched James Bond.
That was meant to be James Bond. Now, two people are trying to enter into my class. One person could enter, the other person could not. Sudipto Poddar. Okay, let you be waiting. Moving on. বুঝছিলাম আচ্ছা আরেকটা প্রবলেম দেখাবো আরেকটা প্রবলেম চুজ করি দেখি কোনটা দেখানো যায় ক্যাপাসিটর নিয়ে একটা প্রবলেম দেখাই ক্যাপাসিটর ক্যালকুলেশন তো আমরা পড়লাম ক্যাপাসিটর নিয়ে একটা ভালো একটা প্রবলেম দেখাই তোমরা তাহলে বুঝবে ক্যাপাসিটর নিয়ে কি করতে হবে Yeah, this is a good problem. Question number 10. Let's give it a try. Hold on, দেখো a capacitor consists of two metal plates separated by an insulator as shown in figure 3.1. Okay. The potential difference in the plates is V. The variation with V of the magnitude of the charge Q on one plate is shown in figure 3.1. You see, now they have specified. This charge Q is the charge on one plate. because the total charge in the two plates will always be 0. There is no point of plotting that. So they have plotted this thing. Charge over here is given in millicoulomb, voltage is given in volts, so we get this straight line. Works for me. You might wonder, sir, why didn't they start the graph with 0? I don't know. They have given this much graph. So what I would understand, for the way this capacitor was connected into a circuit, that for our observation, the capacitor starting voltage, initially the capacitor had some voltage applied across it, which is this much value. And then we increase the voltage that was applied across the capacitor up to this much, which caused the capacitor to store a bit more charge. So that's the basic idea. Okay, explain why the capacitor stores energy but not charge. এটা বুঝা গেছে লিখবা। আমি ওয়ার্ডিংটা তোমাদেরকে দেখায় দেই। ও মাসকে ওয়ার্ডিংটা পড়ো। কোনো কোশ্চেন থাকলে আমাকে বলো। Question number 10. You guys know the answer. That's why I'm not going for the discussion once again. That will be redundant. Questionটা পড়ো। মাসকিনটা পড়ো, এক্সাম রিপোর্টটা পড়ো। কোনো কোশ্চেন থাকলে আমাকে বলো। 1 minute.
Sir, what does charge separation mean?
It means that the total number of protons and electrons in the object remains same, but one side of an object experiences more electrons and the other side experiences equal number of shortage of electrons. বুঝছো?
Chief.
Okay. Examination report বুঝা গেছে সবার? I hope so. কেউ কোনো কোশ্চেন করতেছ না? Okay, moving on. এবার বলছে use figure 3.2 to determine the capacitance of the capacitor. সেটা বের করতে আমাদের এই গ্রাফের গ্রেডিয়েন্ট বের করা লাগবে। গ্রেডিয়েন্ট বের করা খুব সহজ। প্রমাণ যেখানে ভুল করে এই মিলিটা দেখে না। They just take values and directly add the answer. মিলিটা দেখা লাগবে, যে কারণে আমাদের ক্যাপাসিটরের কারেন্ট আনসার আসবে হচ্ছে মাইক্রোফ্যারাডে। তো এখানে দেখো যে A2 তে এটা খুব কমনলি হয়। শুনো, তোমাদেরকে ইউনিট রিলেটেড প্রবলেমের স্টেজগুলো বলি। In your O levels, the question had all the variables in SI unit. In most cases, you didn't have to bother about the unit conversions. In S level, the question had most of the units in non-SI units, but the expected answer was not having any definitive unit. You could write the answer in any unit you want, which is expected to be SI unit, but they did not usually give this kind of prefixes in the answer unit. They did not usually. In A2, the S level is definitely there. For example, it is plotted in millicoulomb, not in coulomb. And the answer is going to have some unit, predefined unit, which is going to have some prefixes. So you have to do your calculation properly. Then and at the end of your calculation, you have to modify your answer to match this prefix. Does it make sense, the change of difficulty level?
স্যার এখানে যদি প্রিফিক্সটা না দাও থাকতো তাহলে
তুমি সরাসরি 10 স্ট্যান্ডার্ড ফর্মে লিখতা।
ও যে মিলিতে দেওয়া ছিল স্যার, তাহলে ওটাই
ইনটু 10 টু দি পাওয়ার 3 - 3 লিখতা, স্ট্যান্ডার্ড ফর্মে লিখতা, মিলি ফ্যারাড লিখতা না।
ও আচ্ছা স্ট্যান্ডার্ড।
যদি শুধু এমটি স্পেস থাকে, ফর এক্সাম্পল যে কোনো জনের কাছে শুধু এমটি স্পেস থাকে, মানে এখানে তো সবগুলো এরকম দেওয়া, এখানে সবগুলোতে ইউনিট দেওয়া দেওয়া
মেনশন না করে দিলে স্যার তাহলে
হ্যাঁ যদি মেনশন না করে দেয় তাহলে তুমি স্ট্যান্ডার্ড মানে এক্স্যাক্টলি এসআই ইউনিট লিখবা, এবং তার সাথে তুমি 10 এর পাওয়ার দিয়ে তুমি ইয়াটা লিখবা, মানে এই
স্ট্যান্ডার্ড ফর্ম।
হ্যাঁ স্ট্যান্ডার্ড ফর্মে লিখবা। আচ্ছা এটা গেল। তারপর বলছে the loss in energy একটু the loss in energy stored sorry. The loss in energy, the loss in energy stored in the capacitor when the potential V is reduced from 10 volt to 7.5 volt. Okay, so apparently what I described a bit earlier was wrong. What they're saying that the capacitor, the voltage across the capacitor was actually reduced from 10 volt to 7.5. So no, they actually given us a bigger region. So 10 to 7.5 would be this much. So you have to find out how much was the energy, or how much energy was lost from the capacitor. There are two different ways you can go for this. Since you have already calculated the capacitance, achana, you cannot go for two different ways. Since the question have already specified, use figure 3.2. Do you see that? Use figure 3.2. So which means that for this question, you are expected to use figure 3.2. So what I would recommend, actually, let me take out this picture. So in this case, we are gonna have to find out the area that is enclosed by this much part. Let me just draw. I just তুমি কিছুটা বলতে নিছিলে একটু ওয়েট করো আমি একটু দেখায় নেই তারপর তোমার কোশ্চেন নিতেছি। So Sudipto Potter have left our waiting room and now Fahim Shahriar is trying to enter. Did Fahim Shahriar get in? Fahim, did you get in? Or did they leave completely? What is happening? I don't know. Okay, never mind. So the question is, this question is asking you to find out the area of this trapezium. So this much. So এইটুকু তুমি area appropriate trapezium formula দিয়ে বাই করবা, এটা হচ্ছে using the figure 6.2. আর যদি আমাদের এটা using the figure 6.2 না বলতো তাহলে আমরা আরেকটা কাজ খুব সহজে করতে পারতাম, সেটা হচ্ছে because we have already calculated out the capacitance of the capacitor, we could have calculated that value by this formula as well, half C 10 square minus half C 7.5 square. এটা দিয়ে ক্যালকুলেট করলেও হইতো। বলো তো এটা দিয়ে ক্যালকুলেট করলে কেন হইতো? বলো।
A plus B square is not equal to A square plus B square.
Exactly. This is the total amount of energy stored in the capacitor at 10 volt. This is the total amount of energy stored in the capacitor at 7.5 volt. So you are calculating these two individual values and then doing the subtraction. What you cannot do is this, half C 10 minus 7.5 whole square. This is entirely wrong. পোলাপানরা অনেক সময় এই ভুলটা করে এবং জিরো পায়। বুঝছো কি বলতেছি?
Yes sir.
এইটার আনসার এবং এই এরিয়ার আনসার এক্স্যাক্টলি সেম হবে if you do take into account for the milli part, but এটা পুরোপুরি ডিফারেন্ট একটা আনসার আসবে, এটা হবে রং আনসার। সো এটা কি হবে সেটা বলে লাভ নাই, দিস উইল বি রং, সিম্পল। সো এটা গেল এটা নাম্বার সি এতে আসি, we have 7 minutes.
My question.
বলো, আচ্ছা বলো।
Sorry, similar to resistance, C is equal to V by Q.
Q by V.
Q by V. Is del Q by del V, right?
No. For a capacitor, C equals to Q by V. Not del Q by del V. But
it would work for this graph because it's a straight line, but it's just like resistance, right? Like resistance is not equal to del V by del I.
Yes.
So yes, in a similar way, C is only equal to Q by V.
Yes.
Del Q by del V.
No.
Okay.
The reason we can still find out the capacitance of this component by using this graph, because
it's a straight line.
It's a straight line that if you extend, it will definitely pass through the origin. You can see it. So this is a origin going straight line. So for this case, del Q by del V is basically V by Q because the lower limit is 0. বুঝে গেছি?
Yes, sir.
Good. Achha, let's go for number C. 3 capacitors X, Y, and Z, each of capacitance 10 microfarad. So they are identical capacitors, beautiful. Identical capacitors are easy to work with. Are connected as shown in figure 3.3. So this is the combination that we have. Do we have this picture? No, we don't. So let's take it out. Let's select it. Yes. Control C. Initially, the capacitors are uncharged. A potential difference of 12 volt is applied between the points A and B. Determine the magnitude of the charge on one plate of capacitor X. এই প্রবলেমটা আমরা কিভাবে সলভ করতে পারবো? Think. আমি কিছু আঁকাআঁকি করি। Total voltage applied across the plates is how much? 12 volt না? So আমি 12 volt এখানে এঁকে দিলাম মনে করো। 12 volt এভাবে একলো, আচ্ছা এভাবে একলো হবে। এখানে একটা গোল্লা দেই। এটা গোল্লা দেই। So we have applied this much voltage across the combination. Question বলতেছে, what would be the magnitude of charge on one of the plate? Capacitors হচ্ছে 10 microfarad. So they are not related to the earlier question. So you cannot use the capacitance that you have calculated for the earlier question. This is a totally new, different segment of question. So come to think about it, how can you process this information? Let me show you the mechanism, and then I'm gonna go for explanation. What I really need to understand, for this combination, this is the disconnected part or the segregated part of the circuit. This is the disconnected part. This much. Do you see it? এই যে ভেতরে যে পার্টটুকু আছে, এই পার্টটুকু এক্সটার্নাল সার্কিটের সাথে কানেক্টেড না। Do you see that?
Yes, sir.
এটা মানে হচ্ছে, what I'm trying to mean by this is, let's say this is the positive end of the battery, this is the negative end of the battery. In that scenario, if Q charge is stored in this capacitor, which means, let's say if this plate is plus Q, this plate should be what? Minus Q. This would essentially mean, because they are all identical capacitors, this one should have plus Q by 2, and this one should be plus Q by 2 as well, which is going to leave us this one to be minus Q by 2 and this one to be minus Q by 2. এই ডিভিশনটা কেন হচ্ছে এটা কি বুঝতেছো?
Yes, sir.
Hold on, খেয়াল করো. This is the disconnected part of the circuit, which means altogether this part has to be uncharged or 0. If you have minus Q over here, that minus Q should be coming from the two plates. Because they are identical capacitors, they should both give out equal amount of charge. That's why this plus Q by 2 plus Q by 2 are equal for both of them. If the capacitors were not identical, then this calculation would have been something different. যেটা তোমাদের সিলেবাসে ইনক্লুড করা নাই, সো আমি ক্লাসে দেখাবো না, but if you're interested I can show it to you or try to show it to you more accurately after the class. But for your syllabus volume, you will always have to deal with identical capacitors, which means if minus Q has to be the charge that has to be on this plate, these two capacitors should have Q by 2, Q by 2. Now, try to understand, since all of these capacitors have the same capacitance and the formula is given by Q equals to CV, C is a constant for all of them, which means for the capacitors, when Q becomes Q by 2, logic tells us that V should also become V by 2, right?
Yes, sir.
Which means, let me show you this with a different color. Hold on, Kalko, if you have question, raise your hand or ask me questions, please. Which means, if this capacitor, I choose a different color. I did not choose a different color. Now I did choose a different color. So it means that if this capacitor has a voltage of V across it, this capacitor, each of these capacitor, because they are connected in parallel, or I can say this entire combination of these capacitors should have a voltage of V by 2 across them. Can you agree on this part? Because Q charge is responsible for V voltage, so Q by 2 charge should be responsible for V by 2 voltage, because the capacitance is same for each of the capacitor. This, after you have done this much calculation, the rest of the part is pretty simple. You can see that in here, this capacitor is in series with this combination, so I can logically write by Kirchhoff's second law, V plus V by 2 equals to 12. Therefore, V equals to what? কত আসবে এটা বলো?
By 3 of 8.
8 by 8 volt. And once you know the V, calculating the Q is very simple, because the charge that we assume over here is Q. Q equals to 10 microfarad, 10 into 10 to the power minus micro 6 into 8. So এখান থেকে আসবে হচ্ছে 80 microcoulomb. Is that the answer? Microcoulomb, okay. Yes. So I'm happy with my calculation, but everyone have a look and see if you have any question. এটা বুঝছো কিনা দেখো.
Sir, this technique works for any sort of capacitor arrangement.
This actually works for any sort of capacitor arrangement. There are more combinations that we're going to work down the line. So I'll be showing you other different problems in the next class, obviously. But this is one of the examples of the problem. The heart of the solving this kind of problem is that disconnected part of the circuit will be neutral. So if just for the sake of discussion, if I just show you another example, I know I'm nearly at the end of my time, but I just want to show you this. If we have identical capacitors which are connected in this fashion, let's say we have 2 capacitors over here and then 3 capacitors over here. Okay, let's say we have a situation like this. Let's say in this case also each of the capacitors are 10 microfarad, and we connected a source of, let's say once again 12 volt across them. বুঝতেছো কি বলতেছি?
Yes, sir.
স্যার
সো মনে করো এরকম একটা সিচুয়েশন আছে, তো এই কেসে আমি যদি বলি যে দিস ইজ মাই ক্যাপাসিটর এক্স, হোয়াট উইল বি দ্য চার্জ স্টোর ইন ক্যাপাসিটর এক্স, এটা যদি ক্যালকুলেট করতে তাহলে কেমনে ক্যালকুলেট করব?
The charge within the disconnected part.
The total charge of the disconnected part of the circuit should be same. So if I assume the charge stored over here is Q, this should also have Q, right? Think, let's say if this capacitor stores Q charge, let's assume, because I'm trying to find this out, that's why I'm assuming this to be Q for the sake of easier calculation. So this would mean that this plate should be minus Q, this plate should be plus Q. Equally, this plate should also be minus Q and this plate should also be plus Q, because they are identical capacitors. It means together these two plates have how much negative charge? Minus 2Q, ठीक ना? Together. Why together? Because they are connected by a single wire over here. This amount of extra electrons must equally come from the positive plate of these three capacitors. These extra electrons must come equally out of them. So what would be the individual charge of these left plates?
Plus 2 by 3Q.
Plus 2 by 3Q, because they are going to drain electrons by equal amount. So together their positive charge should perfectly balance out this one, which means if I divide this by 3 and convert this into positive, that will be the charge lost by this plate. So this should have plus 2Q by 3, this should have plus 2Q by 3, this should also have plus 2Q by 3. Logic tells us that this should also be minus 2Q by 3 and same and same. এই ক্যালকুলেশনটা কি বুঝা যাচ্ছে? It's a basic idea of charge distribution for the disconnected part of the circuit. So now if I go for the same equation set, Q equals to CV, C is a constant. So whenever for Q charge, if I assume that the voltage across this plate is V, so Q equals to CV. So if Q gives you V, then necessarily 2Q by V should give you what? 2Q by V, not 2Q by 3, sorry. 2Q by 3 should give you 2V by 3. So if this part of the circuit, let me just now label it with red. If this part of the circuit has a total voltage of V, this part of the circuit should have a total voltage of 2V by 3. By the law of series circuit, V plus 2V by 3 should be equals to 12. এখান থেকে V by করবা, তারপর Q equals to CV করলে তোমার চার্জ স্টোর বের হয়ে যাবে। বুঝতে পারছি?
Yes, sir.
This is a very basic. The heart and soul of this problem is that the disconnected part of the circuit would have equal charge sharing across its plates on the two sides. কার কোনো কোশ্চেন থাকলে বলো।
স্যার মানে ইকুয়াল চার্জ শেয়ারিংটা সবসময় অ্যাপ্লিকেবল থাকবে even in case of non-identical capacitors?
No, for non-identical capacitor, I mean the left and the right side should be equal, but that this distribution will be dependent upon the capacitance value. I mean the total amount of negative charge over here should be equal to total amount of positive charges over here. The sum should be equal on the left and right side, but whether these three values should be equal or these two values should be equal or not, that is dependent upon the capacitance value. So এখানে কিউ ধরলে যে এখানে যে কিউ ধরতে পারছি এটা অ্যাপ্লিকেবল হচ্ছে কারণ দে আর আইডেন্টিক্যাল ক্যাপাসিটর। সিমিলারলি এখানেও যে ইকুয়ালি চার্জ বের হবে সেটা অ্যাপ্লিকেবল হচ্ছে ডিউ টু আইডেন্টিক্যাল ক্যাপাসিটর। That is dependent on the fact of identical capacitors, that for the individual charge quantity. But the left side and the right side sum, the left side sum should be always equal to the right side sum. That is given for identical or non-identical case, doesn't matter.
Yes, sir, I got it. Thank you.
Sure.
Sir,
yes.
যদি এখানে একটা রেজিস্টার থাকতো তাহলে কি মানে আমার এই যে could I have written যে আমার টোটাল ভোল্টেজ গুলা ক্যাপাসিটরস এর টোটাল ভোল্টেজ তখন অ্যাড করে কি আমি 12 পেতাম নাকি 12 এর থেকে একটু কম পেতাম?
বলতেছে এখানে যদি একটা রেজিস্ট্যান্স থাকতো তাহলে যেটা হতো যে আমাদের পুরো ঘটনাটা ঘটতে সময় বেশি লাগতো, বাট ওয়ান্স দ্য ক্যাপাসিটরস আর ফুলি চার্জড ইউ উড বি এবল টু ডু দ্য এক্সাক্ট সেম ক্যালকুলেশন।
কিন্তু স্যার ক্যাপাসিটর মানে এন্টায়ার ক্যাপাসিটরের অ্যাক্রস আমার পিডিটা কমে যাচ্ছে না, তাহলে ওটা কেন why is that 12 ভোল্ট?
বলতেছি এন্টার ক্যাপাসিটর across the period কমে যাবে না, কেন কমে যাবে না আমি তোমাকে রিজন দিয়ে বুঝাই। Try to understand, when the capacitor charges, what happens? Current slowly dies down, right? So when the current dies down, what happens to the voltage difference that is made by this resistor? That also dies down. That is given by I into R. So essentially all the voltages will be consumed by these two. So that's why I said that when the charging process is finished, all the voltage will be equal to 12 volt, will be consumed by the capacitors only. The voltage, the resistor would become unworthy of any voltage.
Because ওখানে আর কোনো potential drop হচ্ছে না.
Because current is practically zero.
Current is practically zero.
Sorry, even if the capacitors are not identical, the voltage thing, it would be, you could use the voltage rule, proportionality, to find the total voltage, right?
If the capacitors are not identical, you cannot use this ratio. I could use this proportionality, this conversion, because C was a constant.
Because C is a constant, obviously.
Exactly. But you could always use this thing because this is coming from Kirchhoff's second law. That has nothing to do with the capacitor.
Understand, sir.
Okay. Non-identical capacitor হলে ক্যালকুলেশন কেমনে করতে হবে সেটার অনেকগুলো ডিফারেন্ট মেথড আছে। ওই মেথডটা আমি ক্লাসে দেখাতে যাচ্ছি না, but I'm going to stop the recording and call it an end for the official class. Then I can take your additional questions if you're interested. The class is over. Thank you guys very much for the additional 7 minutes of attention for those who were along with us. For those who want to ask extra questions, tag along.